Hi, everyone. I want to talk to you a little bit about the multiplication math fact journey. I've been working on this graphic here to kind of show how it is not just as simple as memorizing timetables. There is a lot of sophistication to this. Literally, there's nothing elementary about teaching elementary math, let me assure you. But I want to share with you about the research behind how our kids can progress through learning their basic facts, but also provide a foundation of learning for their entire math journey. So let me show you a little bit about the beginning of the stages here. Starting in grade 2, we do have kids exploring things arranged in rows and columns up to a 5 by 5 array, and they use skip counting to figure out the total amount that are there. And in fact, many kids will even begin by just counting them one by one. So, the very beginning of our journey here are kids counting all. So, they would see the objects, maybe 4 groups, each of 3 cubes, and they would count each one by one to get the total. They also might do pictures here, like tally marks, but again, they're counting up one by one, also with their fingers. They might do, let's see, for 3 times 4, they might do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're counting every single amount in each of those equal groups. Now that progresses toward skip counting. If they can do 4, 8, 12, then they're able to skip count by that. But sometimes the kids do hybrids. Sometimes they will skip count to a certain amount, and then they find they don't know what the next multiple is, and they count one by one of that next group to get to that next, what would have been the skip counting multiple. So they kind of have hybrids of these stages. But if they begin by counting all, then they go to that skip counting, and it's harder to do with the upper numbers like 7, 8, and 9. And at that point, very often, traditionally in our classrooms, we've gone right to now memorize them. And when they don't know what the answer is, when they're asked a problem, they go back to what they're familiar with, which is their skip counting. Now, I put a dotted line there as a possible journey here, multiplication math facts. They get to skip counting, they go over to the memorization. They're asked to learn them. Many of the kids aren't able to memorize all of those. And so when they're asked a question that they don't know, or even embedded within a larger multi-digit problem, they will skip count and go back to what they know. And some of those don't even know the skip counting amount, so they end up counting as well. So when I ask kids and I interview them about their math thinking, I might ask them, for example, here in 8 times 7, a student has only memorized those math facts. For a student who has done it accurately, what I find is they tell me that when I ask them, how do you know what that answer is? They say, well, I just learned it. I said, okay, so how about a friend who doesn't learn it? How would you help explain to them how they can efficiently find it out? And they'll say, I would tell them to get some multiplication math fact cards and practice them. And then I would ask them a question of 4 times 17 and see what they do with it. And very often, the kiddos who have memorized only will tell me they didn't learn that one yet. They're thinking about these multiplication math facts as being a set of facts just in them own selves, that knowledge in by itself. It's not connected to any other knowledge or mathematics. It's just memorizing an answer and waiting for that number to pop in their head. But very often I find kids who have memorized them, they memorize them incorrectly, and they don't have any reasoning to be able to fix their thinking. So I'm suggesting another alternative, another pathway. And I'm sorry, I'm not alone in this. There are a lot of researchers and a lot of educators out there now working on fact fluency, because it really is a key of changing everything else about their math journey. So instead of going from skip counting and then going right to memorize math facts, this is more of a trajectory for kiddos to get them there to have full understanding. So going to the next step then would be derived facts. Now, derived facts are being able to use facts that they know to figure out ones that they don't know. So I've given you an example here of 6 times 8. Now, we're not ever trying to say to students they need to use a certain strategy with certain numbers ever. Nope. It's just exploring numbers in ways to break them apart to make them easier for our brain into smaller chunks. And in doing so, we're moving them from additive thinking into multiplicative thinking. If they're working on multiplication problem, let's say even a multi-digit one, if they're using the algorithm, they're doing single-digit math facts, and even within single-digit math facts, they're usually skip counting. So they're actually doing an additive thinking in the context of a multiplication problem. Well, we want to even those up. We want them to be working on multiplication problems and using multiplicative thinking, because in grade 6, they get proportional reasoning. So they've got to be prepared for that. So here's an example of how I broke apart 6 times 8 in a variety of ways, because there is not just one right answer. Well, I'm sorry. There is one right answer. It is a 48, but there's more than one way to get to that 48 as the correct answer. So I might think about breaking apart my 6 into 5 groups and one more group. So 5 groups of 8 is 40, one more group is 8, 40 and 8 makes the 48. Or perhaps I like thinking about my 6 facts as being doubles of the 3s. So if I know 3 times 8 is a known fact, which is 24, I can double that to get to my 48. Or maybe I like my times 8s to be doubles of my times 4s. And so I'm visually showing you here how we can use grid paper to show we can do it concretely with manipulatives, and then show it to them here and have them draw pictures to break apart these numbers in flexible ways. That way it supports that kind of journey of understanding the distributed property of multiplication, and they'll be able to do this now with larger numbers, decimals, fractions, and believe it or not, polynomials all the way down, up to high school. So it provides a really good support for their foundational math thinking. So the kiddos that I asked a multiplication running record with them, I interview them about their thinking. When I ask the kids who have some strategy thought processes, what is 6 times 8? They might tell me right away, 48. And then I say, how did you know? Well, I just know it. Okay. What about a friend who doesn't know it? What'd you tell them to do? And they tell me that they could think about how 8 is double the 4s. If they know 4 times 6, they could double that. Or maybe they could break apart that 6 into 3, they could double that. Like they have strategies for explaining it. And they're also willing to try harder ones and not being afraid of it. So when I ask them 4 times 17, they don't know it's 34 automatically, but they say, well, I know 2 17s is 34, and 34 and 34 is 68, so it must be a 68. And that's what we're looking for, to have the kids have their basic multiplication math facts relatively speedy. Again, I want to leave room for the fact and honor the fact there may be some students that are not going to be super fast, but they've got great thinking. In fact, I asked a student on a math running record just a few weeks ago what 9 times 5 was. And he thought for a while. I didn't see fingers come out to skip count. He was thinking for a while, and he finally said 45. And I said to him, how did you just figure that out? He said, well, I know that half of 9 is 4.5, and that times 10 is 45. Now, he's not a super fast thinker, but oh my gosh, that kind of thought process is phenomenal, and it will serve him well with much harder problems down his road. So we need to honor the fact that not all of our kids can get speedy. Do we want them to be? Of course. And I want to work with them to develop efficient ways of figuring these out. But also some may not get there, and they don't want them ever thinking they're not good mathematicians. We all can think and grow and learn with math. So that is my chart. I'm going to put that in a PDF for you to have. But it is the research. I base all this on the research of Sharon and Fuson, their 2005 article, as well as Brody's research on the phases of mastery, to kind of show you that multiplication math fact mastery is more than just flashcards and memorizing. It can open up a beautiful world of mathematics. So again, I'm Annalise Record. Thanks so much for listening in on this, and feel free always to reach out to me. You can find me on Facebook as Annalise Record with a growth mindset tree, or in the Math Running Record Facebook group. Okay, we'll talk to you later.